Hello and welcome to Lesson 8 of Computer Systems for National 5 Computing Science. Last time we looked at the processor. Today we're going to look at memory locations and buses. I love a presentation. Here's what we're learning. But first let's recap. What did I ask you in the last video? State the part of the processor that would temporarily store the value 50. Did you say registers? If you did, you get the mark. And which part of the processor compares values? Comparisons are done by the ALU. It's the logic part. The arithmetic logic unit. Well done if you got that mark. So let's recap a bit more. We've got three parts to the CPU. We've got the control unit, the ALU, and registers. The control unit's in charge. It monitors and controls the other parts of the computer. It also deals with the timings. The ALU performs the arithmetic and the logic. That's what A and L stands for. And registers, there are many registers, but they all store small amounts of data temporarily. But what are we learning in this video specifically? We're going to learn about addresses and how computers store data. So in a computer system, all data is stored in a memory location. So whether that's the registers, the cache memory that you don't need to know about yet, or whether it's RAM or backend storage, all of these locations will have what's known as an address. And just like your own address, your home address, it must be unique. Otherwise, how does the postman know where to deliver letters to? All of these memory addresses, the addresses are in binary, so it's a binary address, as you would imagine being inside a computer system, since binary is the only thing they understand. And when something is placed in a memory address, the computer knows where to find it again, because it's at that address. This is the absolute basics of how memory is stored in a computer system. But how does the data and the instructions get to that address? Or how do we get something from that address? That's where buses come in. Just like if you were at home and you wanted to go into town, you would catch a bus. There are three types of bus that you need to know about. In fact, the third one is just a collection of buses. But let's take a look. Now, in a computer system, a bus is not a big vehicle that you pay to get onto. It's just wires. You can see this demonstration, this little image down here, this example. It's wires. So here are address buses. And we've got some data buses that go all around. And they go to different devices and storage devices and parts of the computer. All connecting to the CPU though. And as you would imagine, the data bus, it carries the actual data. It also carries instructions. If you think about a program, it's just lines of instructions that tells the CPU what to do with the data. So data and instructions can be carried between the CPU and RAM. It's called bidirectional, bi meaning two, and directional obviously meaning two directions. So it can go from RAM to the CPU, or from storage to the CPU. It doesn't matter where it's going from. And it can go from the CPU back to RAM and back to storage, or wherever it's going. Two directions, back and forth. The address bus is unidirectional, uni meaning one, and it takes an address from the CPU to RAM so that the CPU knows where to access or where to deposit the data. So the data will travel along the data bus, and when it gets to RAM, and the address will be carried from the CPU to the RAM, and when the data arrives there, it's like, right, where do I go? It goes to the address that was specified on the address bus, and it goes there, into that address. Likewise, if the CPU is accessing data, it will access data from the address that was sent down the address bus. It'll say, where am I getting this data from? Ah, yes, here's the address. It'll pick it up and take it back along the data bus to the CPU. And finally, the control bus. The control bus isn't a single wire. It's a collection of wires and they all do different things. We've got things like the read line, the write line, reset, interrupt, and there are lots more than these. You don't need to know what they do individually. I've got a past paper question here, the 2019 past paper. When a program is implemented, the water temperature will be stored in the memory of a washing machine's built-in computer. State the bus used to transfer the stored water temperature to the processor. Well, this is data that's being stored. It's not the location that you're storing it in. That would be the address bus. But since it's data that's being stored, this would be the data bus. 1 mark. And next up, explain how a computer system organizes data in memory so that it can be retrieved. You would get 1 mark for stating that it would be stored in an address or a location. And the second mark is for stating that it's a unique location. That might seem a bit strange. But sometimes marking schemes are a bit strange. There you go. Locations/addresses, and they are unique. If they weren't unique, how would the data know which address to go to? Anyway, I hope you've enjoyed this one. I'll see you in the next one.